All right, so solving trigonometric equations. Remember, theta is our angle. You can also use alpha if you like. You can also use beta. These are just the angles that are nestled in sine and cosine. I want you to remember that a function is the key word here. Function is for any input, I get exactly one output. So if I put an x into the function, I should get out a y. So that's kind of what the definition of a function is. So think of these, sine and cosine are functions. They're functions. So sine and cosine are functions. And what we're trying to do when we solve a equation with the trigonometric equations is that we're trying to kind of get sine and cosine kind of by themselves, or maybe eliminate one, because when we plug that answer, we plug theta into both of these, it would give us whatever's on this other side. So let's go through a couple of these, and maybe this will kind of click. So I have this example up here. This is sine theta times cosine theta equals negative 1/2. Now, I usually like to do this because it tells you where our restrictions are. So I'm going to say let the restriction be from 0 theta to 2 pi. So our restriction is really just one time around the unit circle. If this is not there, we would specify another way of looking at this. But this is one time around the unit circle. All right, so let's go ahead and try this out. And here we go. So I'm looking at this, this function, and I don't think I can do too much on this side. So I want to kind of see, what can I do here? All right, remember that you're looking for identities. You're looking for identities. So this, if I look at this, so here's your identity that we need to kind of look under it. So we have to do this. I kind of see this identity and I'm thinking, what can I do? What it kind of tells me there? Well, if I take this identity, and I think it's sine, I do believe it's sine of 2 theta. I think that looks like an identity. Now, how am I trying to do that? Well, I'm trying to kind of come up to something like that. I'm trying to kind of come to this example here. So what if I take this and make it this identity? And you're probably thinking, why would I do that? Well, let's just try things. Let's just try something. That's the reason we want to try this, because it's kind of like the premise of this, the idea. So we're thinking of this, and we have 2 sine theta. However, I want you to understand that this is also 2 thines. This comes out to that. Now you're probably thinking, well, I don't have a 2 right here. But that's kind of the idea that we're shooting for. So that is good. Can we use this identity still? Well, yes, you can. So I'm going to just replace this part with 2 sine theta. So I'm going to go 2 sine theta, and I'm going to go 2 cosine theta equals negative 1. And you're probably thinking, how did you get from negative 1/2 to negative 1? Well, think of it this way. As long as I, remember, this is an equal sign. As long as if I do something to this side, I have to do it to this side. If I do something to the right side, I have to do it to the left. So if I multiply by something here, I have to multiply by something over here. And here's kind of like the way to do this. So I took this, this negative 1/2, I multiplied by 2. And then I have to make sure I do it over here. And if you multiply both sides by 2, guess what you have? Look at this. I have that identity. I have that identity. And that comes out to here. So you're kind of looking at these identities a little bit, and you're kind of going back and forth sometimes. And I'm not trying to make this complicated, but you can make it complicated if you are thinking about that. And you're probably thinking, okay, how would this go? Well, let's think about this. This part right here, is going to be, I do believe it's sine 2 theta equals -1. And that's a double angle identity. All right, so here's what we're going to do. Remember that we are in the process of 0 to 2 pi. That's our restriction. We can't, that's one unit circle around. And so let's kind of look at this angle here. Let's look at this angle right here. So I want to kind of look at that. Well, you're probably thinking, what angle will give me 2 and then give me -1? So here we go. What if I take 2 times, let's do, let's do negative pi over 4. Why pi over 4? Because I'm kind of seeing, can I get -1 from this? So if I get -1, let's see, if I multiply both sides, that's 2 pi over 4, and I'm going to have negative pi over 2. Now, I want you to look at this part right here. Is sine of negative pi over 2, is that -1? So if we draw our unit circle, and I do believe pi over 2 is over here, and that is what? Is that 0, 1? Well, that's not going to work. Well, where is -1 at? Well, -1's over here, so that's -1, 0. Well, that's not going to work. So let's go down to here. 0, -1. Okay, there's sine right there. So our answer for this one is going to be 3 pi over 4, because we're trying to think an angle double it gives you -1 from sine. So that's kind of another way of kind of thinking about this. I know that this is really hard for a lot of students. I mean, because you're kind of solving, you're kind of dealing with things, but it does make sense as the more you go. So I want to do a word problem. So let's do this one right here. What if I had 1/16, I had velocity squared, sine theta, cosine theta. And if you don't know anything about like physics or this kind of equation, this is kind of like you have a cannon here, you have a cannon, it explodes a ball or something like that, a cannonball, or maybe a baseball player, football player throwing a ball. And this part right here, I do believe this is called the range in a physics class. And the height is up here. So remember that you're kind of going this distance, but you're also going the y distance. So you can kind of think of this as like your cosine, and this is your sine. That's kind of where it comes from, the unit circle. So anyway, that's where this kind of comes from. What I want to do is take this equation and I want to show this one. I want to show this one. And I want to show this one. I want to show this given. So I'm going to give this. This is given, but I want to show this, and I want you to understand this. If I'm given this and showing this, if I just take this one right now and ignore this one, so I'm going to rewrite this one over. Okay, I'm going to rewrite this over. I want you to think about this. If you see this right here, are you thinking of an identity? Are you thinking of an identity? Do you see that I might have an identity of that somewhere? I might have an identity of that somewhere. Well, if you are given this and you're showing this, think about this. This one you're trying to get to. You're trying to show this one. That identity is close to this. There's only one thing missing here, is a 2. So what if I take this? So let's just kind of, if you want to, let's take this one here. and go 1 over 32, or 1 over 32 velocity squared. And I rewrite this one as 2 sine theta cosine theta, because that's an identity. We're kind of showing that one. We're given this one, but we're trying to show this one. Well, look at right here. This is 2 times all this junk. And if you kind of do your fractions kind of nicely, this should be all over 1. This is 1 times that divided by 32. Well, if you have a 2 on top and you have a 32 on top, doesn't that go to 1 over 16? B0 squared sine theta cosine theta, and you have it. And that's what you needed to show from that one to that one. Or this one, I should say. All right. Well, that's kind of like a word problem that you're kind of looking at another equation sort of thing. So let's do a couple more solving ones. And let's try this one. Let's go 4 sine squared theta minus 3 equals 0. All right. If you want to put a parenthesis, that's fine. I'm not going to give you a restriction. I'm not going to give you that restriction. So remember last time I gave you between 0 and 2 pi. I'm not going to give that to you because I want to show you what would happen if we're not given this restriction. So here we go. So you're probably thinking this. You're probably saying, okay, where do I start? Well, first off, I want you to look. Look first. Do I see an identity or see something I can do? Do I see an identity? And you're probably thinking, all right, I see something that I can kind of maybe pull off here. So before I start anything, maybe it would be nice to kind of take this 3 and move it over. Because remember, we're trying to solve for, we're trying to do this. We're trying to get sine. Because remember, that's a function. That's a function. So let's try to get that by itself. So I'm going to go 4 sine theta equals 3. Well, remember, I'm trying to get just a sine, because that's a function. I'm going to divide by 4. So I'm going to go sine theta, and I'm going to go 3 over 4. All right, that looks a little bit better. All right, I want you to understand this. This part right here is the same if I written like this. That is the same. So this is the same. We just like the 2 being nestled inside. So you're thinking about, I need just to get a sine, so I'm going to take a square root. Because I want to get rid of that and get rid of that. And guess what you have? You have a nice, lovely sine. But then you have a little bit of square root business. You can take care of that. And remember, this is positive and negative, the square root of 3. And if you don't mind, I'm going to make that a 2, because what's the square root of 2? Sorry, what's the square root of 4? Isn't that 2? And so we don't need to rationalize, but we have this, and that's good. All right, now we have to be very careful here, because I didn't give you a restriction. And here's what you're going to do. You're thinking about, where does theta of sine of pi over, square root of 3 over 2, where is that on the unit circle? So we have to look about this. And if we do that, I do believe that's 60 degrees. And there's another one I do believe at 120 degrees. And there's one at 240 degrees. And I do believe it's 300 degrees. So you have 4 places that this works. And we kind of have to be careful here, because remember, I didn't give you that restriction. So here's what you're going to write. You're going to say, okay, the angle is going to be 60 degrees plus 180. Let's make it K. K is kind of the number of times around the unit circle. The number of times. Now, by the way, if you don't know what this is, it just exists. It's like a cheaper way to kind of say there exists a K. That's just another, it's like a backward E. It's the number of times you are going around. And there's only 60 degrees plus 180. So that's half a circle times how many times you're going around the circle. And I want you to be very careful here. Do you remember this part right here? And if we look at a unit, look at the quadrants, all students take calculus. Do you remember what sign is positive in? Isn't that quadrant 1? And I do believe that's going to be quadrant tangent sign. I do believe that's going to be 270 here. Okay, you're looking for where is sign positive at. Here we go. So I guess we're going to have to write 240 plus 180 plus k. Now I want you to understand that 180 is a half a circle. Well, this is your answer here if you weren't given a restriction. Now you're probably thinking, what if I was given this restriction? Then you'd probably leave it like that. If you did not give this restriction, so if you were given this restriction, that would be your answer. If not, that would have to tally onto it. So let's do a couple more. Let's make this a little bit interesting because we like interesting in math, don't we? So 2 cosine theta, sine theta, and let's equal cosine theta. So we have something like that. Now, remember, our goal is to kind of get cosine or sine out. Because remember, these are functions. So really, yeah, you kind of are solving for theta, but you're kind of dealing with a function here, or an equation, I should say, too. All right, so here's what we're going to do. Where do we start? I'm going to start here. Do you see why? It looks like I have an identity. I recognize this identity. I know that this identity is going to be 2 sine theta equals cosine theta. Is that correct? And I recognize that. However, does that help you? Does this help? No, I would not care about that. I would just leave it like this because that didn't help you. That didn't help us. But what if we were given that? Then I would go to there. So I would just leave it in this fashion. I would just leave it here because that's that identity. All right, so we're back to this one. So what are we trying to do? We're trying to get sine and cosine. So any ideas? Well, the idea is I'm thinking that I have cosine here, cosine there. Let's go ahead and subtract a cosine. And equaling to 0. I have cosine here, cosine here. I'm going to bring out a GCF of cosine. And the reason I'm bringing out a cosine because I have a cosine, well, that means if I can take out a GCF. And that's going to be 2 sine theta minus 1 equals 0. I want to make this clear that I do believe we have to solve for 0. We have to make them equal to 0 in order to do this next step. So our two setups, this is a multiplication. And I do believe, according to the zero product property, remember when you have something like this equaling to 0, I don't know, x plus 4, x plus 3. Remember, you're going to have x plus 4 equals 0, x plus 3 equals 0, and then solve for 0. That's kind of the idea behind that. So that's why we had to move that cosine over there to take out that cosine. Now we have this cosine equals to 0. And we have this equaling to 0. Now guess what you have to do? This one's done. This one's done. So we're done with that one. We got to solve for cosine here. We got to solve for sine. So here we go. We're going to go 2 sine theta, move this one over, divide by 2. And that would give you 2 sine theta 1/2. And that one's done. All right. Let's try this. If I give you go back up here, if I give you a restriction, actually I should make that theta, huh? If I give you this restriction, this is what you're going to write. So I give you that restriction. Where is cosine 0? Where is cosine 0? You're probably going to think, well, theta should be at cosine 0 is 2. Or sorry, pi over 2. Where is 1/2 of sine going to be? Well, I do believe that's pi over 6. Now, pi over 6. And I do believe there is another one, pi over 6, and I do believe it's 5 pi over 6. So you got 2 answers to this one, and this one, you got that. So a total of 3 answers. So you have a total of 3 answers. 1, 2, 3. And that was given this restriction. This should be theta. Okay. So I'm hoping that kind of made more sense there. Let's do another one. Okay, so let's make this a little bit more, I want to say extreme, because I want you to kind of get this. So let's go 2 sine squared x minus 3 sine x plus 1 equals to 0. So this is kind of another identity that we want to solve for. So in this time, I put x instead. So remember, x is really just theta. X is just theta. It's just another way of saying theta. Anyway, we're going on. Then we're probably thinking, okay, where do we start? Where do we start? Well, that's kind of the tricky part of these, because you kind of say, well, I see this. I know that this is an identity. Should I switch that identity? I wouldn't jump to that conclusion yet, because I want to show you something here. I want to show you something. So here's a little hint, or maybe an alternate way. If this is too hard for you, here's an alternate way. Do you see you have sine squared and sine plus 1? Let's do this. Let's do a little substitution. Let's do a little substitution. Let sine of x equals, why don't we call it u? Let's just call it u. Why do I want to do that? Because I'm trying to make it easier for you to see. I'm trying to make it easier. And I can do that. I can call this u, because it's the same thing. Just change it back. Change it back when you're done. So let's just call it u. So that means I'm going to let sine x u. So let's go back up here, and let's go 2u squared minus 3u plus 1 equals 0. Now, do you see something like that? I like this because it looks like a quadratic. It looks like a quadratic. And you know how to solve quadratics. It's pretty straightforward. You do some factoring. As long as you put u back at the end. You can do this step. It's just an alternative way of seeing this. So here we go. So we have to kind of factor this. So kind of do this. 1 times 2, I do believe it's 2. Put the -3 down below. I'm thinking about what 2 factors. Multiply and add to this. And I do believe that's that 1 and 2. So 1 times 2 is that. Oh, wait a second. They both have to be negative, don't they? Because that and that make that, that and that make that. So we're cool. All right. But remember, this is greater than 1. So you have to kind of do that little bonus method that we call it, right? So that's going to be 2u squared minus u, really, minus 2u plus 1. And I do believe that's equal to 0. Okay, so split that up and try to get the twins, identical twins on both sides. So I can take a u here. I can go 2u minus 1. Can I do the same thing here? Well, you're almost there. So you might want to take out a negative. So you have 2u minus 1 equals 0. Look at that. Here's the two identical twins. That's a factor. Remember, this is like a 1 right here. So that's going to be u minus 1 equals 0. All right. Now let's solve for u. So let's solve for u. That's 2 equals, so 1. U is going to be 1/2. If I add, I get 1. All right. So here's your answers. But remember, u is equal to sine. So let's take this back and go sine of x equals 1/2. And sine of x equals 1. And there you go. So where is that going to be in our unit circle? And I didn't give you a restriction. So what are you going to do? Well, here's how you would play this out if I didn't give you a restriction. This is going to be, I think, okay, let's do this real quick though. 1/2, I do believe it's going to be pi over 6 and 5 pi over 6. And this one, I do believe it's pi over 2. So technically, here's your 3 answers. But remember, I didn't give you that restriction. So here's how you write it. So you're going to write like this. Pi over 6 plus 2 pi k. Because remember, you're going to go around the unit circle to that same spot. And the other one is going to be 5 pi over 6 plus 2 pi k around the circle. And also include the same thing with pi over 2 plus 2 pi k. Technically, that's going to be your answer without restriction. And I guess we could say this is with. So that's kind of the idea behind this, is that if you kind of see that happening, do a use substitution and make it easier on yourself. If you didn't figure that out, you could still solve this with this. And you're probably thinking, well, what if this was a cosine? Sadly, you can't do this. You can only do this use substitution if you have sines here and here, or cosines, but not if you have sine and cosine. So this won't work with sine and cosine. It has to be both together. All right? And let's go ahead and try one more, and we call it on this. So let's try this last one, and I will make this one kind of fun. We like fun, don't we? So let's go ahead and call this, what about 2 sine theta cosine theta plus cosine theta equals 0. Last one. Take a cosine out. Take a cosine out. take a cosine out because I have cosine and cosine. So that's going to give you 2 sine plus 1 equals 0. And remember, zero product property. And let's go ahead and solve this. So that one's done. And let's move some of this over. So we have 2 sine theta equals -1. Sine theta equals -1/2. And that one's done. So we have to think about, where does cosine 0 going to meet? Well, I do believe that theta is going to be 90 degrees and 270 degrees. So that's that one. And I guess maybe I should put a restriction on here. So let theta be between 0 to 2 pi. So there's your restriction. So we can just leave it just like this. This one, I do believe -1/2. I think you have to go backwards on this one. No, not go backwards. That is 210 degrees and 330 degrees. All right. Hopefully this made sense. I know that this is hard, but there's a few tricks. Like I said, you have to try about 100 of these to kind of see the application to this. So hopefully that made sense. All right. Thank you.